So in order to do arts with Desmos, here are a number of equations and their graphs that can be used, and then these are the ones, and then manipulated with these here. So let's get started here. Straight line. Notice that I'm in this folder here. I'm just going to hit enter, and then I'm going to here, and I'm going to do my straight line. So y equals 3x plus 4, for example. And notice that at 3x this is pretty steep. So when I have a 2x there, that's not as steep. When I have a 1/3 x, it's relatively shallow, right? And then this number in the back here either shifts it up or it shifts it down. There you go. I'm just going to leave it at this one for now. All right, polynomials. That one would be, for example, the parabola, which would be x squared. And I'm going to write it in this way. 2 times x minus 3. There's the squared right here. There we go. So that's actually an x squared as well. So there we go, plus 4. And there's the parabola. The reason I wrote it a little bit different than what you might have seen is that I can manipulate it a little bit easier. So notice when I change the minus 4, it will either go up when I go to a smaller negative number. Notice it went up, or even further up. There we go. When I manipulate that minus 3 here to, for example, minus 5, it actually will shift to the right. When I make it smaller, there you go. When I put a 0 here, then it shifts to the left. And when I put a plus here, then it's going to shift to way to the left. So that's the parabola. I'm going to do the cubic next. So the cubic would be x cubed. And again, I'm going to write it differently because it's going to be a little bit easier for me to type in here. So for example, I have x minus 1 times x minus 2, and each time it actually shows up, there's the parabola again, all right? And now I'm going to make it into a cubic, and I'm going to do x plus 1, and there we go. That's the cubic, the way it looks like. I'm just going to go one more, which is the quartic, in order to save myself some typing. I'm just going to copy this one here and put another one in the back. So x plus 3, for example, and that's how it would look like. And I'm going to turn the others off so we can actually see it. Notice that for any one of these here, by the way, I'm going to turn them back on. There we go. In fact, I'm going to move that parabola further to the left. There we go. Got a little bit out of the way, and I'm going to move that straight line a little bit further down, like this. There we go. And then we can see these here a little bit better, perhaps. And by the way, I do not know how to shift them very well. Notice that for any one of these, I'm actually using relatively small numbers. So 1, 2, 3 is preferred, a 0 perhaps in there, respectively a 5, I guess, or a 4, but not outrageous large numbers, not even large numbers, just small ones, because otherwise it would just go off the charts. So notice these are actually all polynomials. This one here is x to the first power. This one here would be x squared. We have 3 x's here, so that would be x cubed. And here we have x to the 4th. And yeah, 4 x's here, so we have x to the 4th. And notice how it progresses here. There's the parabola, then here's the cubic, then here's the quartic. And you can imagine that the next one, which would be the quintic, would continue on like that. But as far as polynomials are concerned, I want to stop there. So the next one I want to do is the circle. The circle would be really easy to type. There it is. All right. I'm going to turn the others off here for a time being. There we go. Notice what's different now is I have the x squared and the y squared. Not only have I the y on the same side as the x, but it's also a square, and that then gives me the circle, which is different from the polynomials, so it's written differently. Over here, I could have just written 16, but this is easier to see when I write 4 squared. Notice 4 is the radius, right? And I can see it right away. If I wrote 16, which would be the same curve, by the way, there it is, right? It's just a little harder to see, so I'm just going to write 4 squared. There it is. All right, I'm going to actually get rid of this here and start over again. I'm going to open the parentheses. Oops, I said start over again. There we go. x minus 4. Here's the square on the x. Go 1 over plus y minus 3. Parentheses. There's the square. There we go. Go 1 over equals, again, 4 squared. Here's the radius. So what I put in here now, and notice that my canvas is only limited. So this one is the circle being shifted somewhere. So if I change this one here to -1, I shift it further down. If I shift it to +1, it's even further down. There we go. And the -4, if I want to shift it to the left, then I would say, okay, I get to a smaller negative number. There we go. Shifts to the left. If I really want to be on the left, there it is. Again, if I want to go up here, then I would say, all right, add a 0 here instead. Oops, try to add a 0. There we go. Or subtract a 2. There we go. So that's how you shift that circle around. I'm going to put it to the upper right, which means I'm going to give it a relatively large y here, -5, and a relatively large x here, -6, in order to get it out of the way of the others. That's not too bad. All right. Just so that as I'm adding curves here, they're a little bit out of each other's way. All right, next one is going to be the ellipse. It's going to look relatively similar to this one. I'm going to copy this so I don't have to type too much. I'm going to put a 1 here instead. So I do it with ellipses, and then here it gets interesting. Divide by 4 squared. There we go. Divide by 4 squared. And notice that's actually the same circle. Again, I'm going to turn these others off here. So that's the same circle, just written differently. However, this one allows me now to manipulate it to become an ellipse. First, I'm going to shift it over there. Let's see, a little bit closer to the y-axis. There it goes. And now I'm going to manipulate these denominators. So instead of having a 4, I'm going to have a 2. There we go. Instead of having a 4 here, I'm going to have a 6. There we go. I want to shift this further down, for example. So quite a bit down, plus 2 perhaps. There we go. And there is the ellipse. All right, next one is the hyperbola. Ooh, I accidentally deleted that. Didn't mean to do that. There we go. Hit enter. And I'm going to, so I copied it and I pasted it again. So obviously it's the same ellipse. And here is the way to the hyperbola. All that happens is turn that plus into a minus. And when I turn this one off here, there's that hyperbola. And again, I can manipulate this one here, so I can say, okay, that's a 5, for example. And this one here is also a 5. There we go. Notice they're getting further apart. They're also getting a little bit steeper here. Of course, again, I can shift this one here, so a -2 here will actually shift it up. That kind of thing. Here's my former ellipse, by the way. If I turn them all on, well, I'm getting quite a mess here. By the way, when you hand this project in, I want to see all of these here at once. Okay. For now, I'm going to turn them off, and just a few more. Next one is going to be an exponential. We're back to y equals something, so e to the power. It already knows what e is, that 2.71 there a moment ago. So in the exponent there, so 2 times x plus 3. The plus 3 in here is again a shifting here, and so is the plus 4 here. And there would be our exponential curve, pretty steep. And I can apply a plus 1 here, that shifts it down. I can apply plus 1 here, and it shifts it to the right as I make that number smaller. When I make this number into the negative, it shifts it way over there. Notice that the exponential really doesn't look all that interesting, by the way. It's an important mathematical function, but for graphing, I don't know. I just put out here, by the way, the inverse function of it is the logarithm. So I'm just going to do logarithm of x plus 3, for example. There it is. And again, for an art project, I don't know how helpful either one of these is. Could be applied, I guess. Here are the trigonometric function. Of course, they are pretty. So here would be the cosine. 2 is the amplitude for the cosine. By the way, let me turn this off here. There we go. So 2 times the cosine of something. This one here is, by the way, the frequency, the 1/2. Right now, nothing happens. We just see a straight line there. But now something should happen. There it is. There's the cosine. And plus 3 here. And again, if I want to shift it here, then I have like a -2 here. There it's shifted. The sine, by the way, looks basically the same as the cosine. So if I change this one here from cosine to sine, then there we just go. It's just shifted. And finally, the last one here is the tangent. I think, again, I'm going to copy this one here and put tangent here. There we go, and I'm going to turn the others off. And yeah, that looks quite a bit different than these others. All right, I'm going to give myself a little break, and then I will show these things here, and a few things on Desmos. And by the way, a few things I have already shown. Again, a little break here. All right, so of this list here, this one, I meant to highlight this. These vertical and horizontal shifts, I've already shown these. That's what I manipulated these numbers here for. Vertical shift here, horizontal shift here, pretty much all of them. Stretching and squeezing, let me show you that. I've done a little bit already. This works quite well on a sine, for example. So here would be a stretching of this one. So if I put, instead of a 2, I put a 4 there. There we go. Or I squeeze it down. There we go, right? So let's see if there are others. For the ellipse, for example, if I turn this one here on, and I'm going to shift it, let's see, I want to shift it up so we can see it a little bit better. Yeah, here the squeezing is a little bit different there, for example. For others like the parabola, if I turn this one back on, this here would be really stretching it upwards. So if I put a 6 there, notice how narrow it gets, and if I put a 1/4 here, notice how wide it gets. All right, let's see, that was the stretching and squeezing. This one here, I'm going to leave it out. I might show you at the end of this little video here, but it would be too much for us. Okay, this one here will be important for an art project, because when you turn these on, yeah, you don't want to have all of these here on there, okay? That means, I mean, the curves there, but you don't want to have them just go all over the place and just continue on. So I'm going to say that, okay, maybe I only need part of a curve. So let's see which one I want to take here. Yeah, this one here, the ellipse. Oh, I left the parabola on. All right. So let's say I want to have only the upper part here, at least part of it, and in the vertical, of course, I have the y, and the horizontal, I have the x. So I'm going to look at the y, because it's in the vertical, and let's say I want to have it only above 3. So what I'm going to do here is space, squiggly parentheses, and then I'm going to say that 3 is less than y, and notice what happens. And here is the squiggly parentheses again. So that's what it does. Sometimes I typed in less than. I can also type in less than equal. Notice, but it didn't make much of a difference, right? For my parabola that I had on here, there we go. Let's say I want to have only the right half to be shown. So over here. So I'm going to go in there and I'm going to say, all right, squiggly. And this one here looks like a -5. So -5 is less than x. There we go. It only shows that. Okay. Let's assume that I only want to start over here. So I'm going to have -3. And it only shows that. And let's say that, well, I'm just going to take this one out here for a moment. Okay, it totally takes it out. Let's say I want to only have it from here to here. So I want to cut this part off. I want to cut that part off. So what I'm going to do is, is to say that my smallest one here is over here, which is kind of neighborhood of, negative, let's make it here, negative 7. Negative 7 is less than x, right? And then I want to have it stop over here. Let's make it, it stops over here actually. So let's stop it here, negative 3. So less than negative 3. And there we go. That is almost like half a mouth, right? Or maybe if I put a face, then hey, there's the mouth there. All right, let's see. So this one here, these x, y intervals, where I shorten this, they come in very handy for many of these. And when I apply this one here, show my other curves, I think I apply a number of them. The shading. Let's look at the shading. I'm going to turn the circle on. I think this was the circle here. I'm going to move this one over here. And instead of having equal here, I'm going to make a smaller than. And my circle is filled out. And by the way, you see that dashed line there? I hold this down here, and I could change the line. At least I thought so. No, I can't find it. Yeah, there is actually a way to not have this one a dashed one. Oh yeah, I know, because I told it so. I might make the smaller one here, so it's totally shaded, that's what I wanted. But if I put a less than equal, there we go. So now the perimeter is in here as well, or the circumference. And again, if I wanted here, I could say I go one over, and I'm going to say, okay, only the upper half. So parentheses, 5 is less than y, parentheses, and let's say I want to have only the left half of that, which means a quarter there. So I'm going to start over again, the squiggly parentheses, and it's going to be, let's see, x is smaller than 4, I believe. No, 6, I believe it was. There it is. There we go. And maybe I'm even able to put them in the same squiggly parentheses. Let's see if that's true, what I just said. Yes, I am. No, I'm not. Oh, that looks, okay, that looks, I didn't know that. That's actually what it cut out. That's not what I intended to do, but okay. So that's possible too. Let's try another one here. This one here was the hyperbola. So I could here, for example, say, okay, I want to have this one here be y is greater than 2. There you go, it cuts it off there, right? Over here on the exponential, they're not really that great for graphing here. So here I could say, for example, I want to have x is less than 2. There we go. Right, and that doesn't look like much of anything. But yeah, I'd like you to do these here as well. And let me shade a couple more here. Let's see what we have here. Here's that. Yeah, especially, oh yeah, especially I want to cut this one off because there's just too much there. So here I could say, okay, my smallest x should be here perhaps -2. Nah, -1. -1 is my smallest x. There it is. And my largest x should be, oh, perhaps +3. I can see that. There we go. And this one here, 2. There's also, yeah, way too much here. So here, I'm going to make this really funky. I'm going to say my largest y is 4, and my smallest y is -1. So I'm going to go in here. -1 is less than y is less than +4, and there we go. Now, yeah, that looks really funkier, I believe. Okay, I just paused and I'm resuming. I'm going to do the moving animated another time dashed line here. I kind of showed that a moment ago. If I go, for example, here is my logarithm. So if I hold this one down, now there it is. I can change this one here to a dashed line. And what else was on there? Thicker, thinner line. So I can go on the same one here, hold down here, and then I can make the line. It's at 2.5, so I can make this one a 7. And notice how Fitbit gets, right? And here are the others. And here again, I can also say, all right, just on the right-hand side here, let's say from 3 to 10. So 3 is less than x is less than 10. There we go. So I like to manipulate the curves that you're presenting to me in this pre-art. It's already art, right? It's abstract art, right? So as you present it to me, I like to do the same here, manipulate each one of them. So yeah, I didn't show the moving and animated one, but I kind of promised to show you the rotation, so I just put this link in here. And here's, for example, a parabola. That's the typical way to draw the parabola. And this person here just really programmed this one here. And if I change this to another one, such as the sine of x, there we go, and notice what happens. So I thought that looks pretty cool, but notice the code that's in here, that really goes beyond of what I want you to do. So for this project, what I'd like you to do is graph all of these here and manipulate them with the way I showed you. So cut some of them off, only give me parts of it, shade them and so on. Let's see what happens if I shaded the cosine here. Is that actually still on there? So if I do this one here, there we go. Yeah, or if I do the same thing with the sine here, larger than, there we go. All right, that's it.